Okay, welcome to the second video on permutations and combinations. The last video that I recorded was about just combinations where we're talking about NCR and we're talking about selecting people or objects from a given number of objects with different restrictions and so on. Today, what I'm talking about is permutations. The first thing that should know about permutations is now we're talking about arrangements. So we're not just talking about selections, but we're also talking about arrangements. So these questions will sometimes have just arrangements, and sometimes they have selection plus arrangements. Okay. Now, this video is about permutations of letters. You have questions where you are given a word which has certain letters, and we'll talk about those questions. And we'll also talk about combinations of letters, and we'll see how that is different from combinations of other things. And there is a small difference, and I want you to be aware of that, and we'll look at it when it comes up. The best idea here is that if I ask you simply that how many different arrangements are there of the letters in the word sand. Okay. So whenever you are talking about arrangements, what I would encourage you to do is I would encourage you to put dashes. Okay, there are four dashes, and I am asking you for the arrangement of all of these letters. So four letters, therefore four dashes. Now permutations are about understanding how these dashes shuffle around between themselves. So for example, if there are four dashes, so I'm going to say that there are four factorial ways of shuffling around these dashes or arranging these dashes, each of which is carrying a letter on it. So 4 factorial gives me 24. Okay, factorial is something that you have on your calculator. It may be in a different place in your calculator. I'm just showing you in my calculator where it is. So I type 4 and then I go to catalog, again probability, and here you see factorial. It's an exclamation mark sort of, and when you execute you get your answer. Okay, what the calculator is doing at the back is 4 factorial means 4 into 3 into 2 into 4 into 1, 4 into 3 into 2 into 1. Okay, so that's what the calculator is doing at the back. Now, there is a small catch when we are talking about arrangements of letters. So let's say I change the word. I'm going to copy this question because I don't want to keep repeating it. I'm just going to change the word at the end. Now I'm going to say how many different arrangements are there of the letters in the word dollar. Okay, so again, I'm going to put out six dashes because I'm arranging six letters, all of them. I'm not choosing letters right now. So there are six letters. So I'm first going to say 6 factorial, but I know that some of these letters are identical so that they don't create a different word or a different password for that matter. So if I'm asking you to arrange letters and make a password, they don't create a separate password. Okay, so these two letters are sort of double counting a lot of things. So how do you remove that double counting? You divide by 2 factorial because there are two L's. So the number of repetitions is divided in the denominator. Okay. I can make this more complicated and I can ask you for the arrangement of the letters in the word. Let's say this time, I have pepper. Okay. So first I say that there are six dashes. So 6 factorial divided by. I see that some letters are repeated. How many repetitions? P has 3 repetitions, so 3 factorial, and E has 2 repetitions, therefore 2 factorial. Okay, that should give me a final answer. I'm going to calculate the one on top as well. 6 factorial divided by 2, this was 360, and this is 60. Okay, so you can see that the number of arrangements start decreasing because there are so many repetitions. So yeah, okay, there's so much double counting that there are repetitions. Okay, that's the basic idea of permutations of letters. We use factorials to do it, and we'll now go on and see what we have to do in these questions. Okay, one part one says find the number of different arrangements of the letters of the word Mexico. Okay, so it is just how many dashes? One, two, three, four, five, six. So 6 factorial. Are there any repetitions? No, there are no repetitions. Let's go on to part 2. Find the number of these arrangements which begin with the letter M. So I'm putting M on a M at the start. It is certainly coming up on a dash, so I've written it because it's fixed there. It cannot move around. The rest of the dashes are there and they can move around between themselves. They're carrying letters. I don't know which letters they're carrying, but they can certainly move around. So I'm going to say that how many dashes are moving around? 5 factorial dashes. Are any of them identical? No, none of them are identical. Therefore, that is the correct answer. Now, the question changes a little bit. It says 4 of the letters of the word Mexico are selected at random. I'm talking about selections. I'm not talking about arrangement. So this should immediately remind you of NCR. Find the number of different array combinations if there are no restrictions on the letters selected. So how many letters do you have? 6. And you want to select 4. So 6C4 NCR. Okay, that should give you 15. Then part 5, it says the letter M must be selected. So I write M as it is. I'm not writing it on a dash because I'm not putting out dashes because this is a combinations question. This is not a permutations question. So I'm going to say that we have M and I need to select how many more letters. Since I wanted to select a total of 4, I need to select 3 more. So I get 5 C3. Why 5? Because M got eliminated and I'm left with EXICO. Okay, and I have 5C3 there. Okay, so let's see if I get the correct answer. Yes, I'm getting the correct answer. 5C3 is certainly 10. Let's look at the next question now. Find the number of ways in which the 9 letters of the word Tennessee can be arranged. Now, I have a habit of collecting my identical letters first, and I start writing the letters like that. I am taking up each letter and seeing where it falls. So, that's how I've written Tennessee in terms of its identical letters. So I can see there are 4 E's, 2 N's, and 2 S. Okay, so whenever I'm arranging them, I will have to see if they have been arranged in the numerator, then I have to divide them in the denominator to make sure that I am not double counting any of these. Okay, if all the letters E are together. Okay, now remember that whenever you want to keep something together, you make a box and decide how many elements are there inside the box. You said all the letter E's are together, so there are 4 dashes inside the box. Okay, and the other 5 dashes are outside the box. Now, whenever you have such a case where you want to keep something together and you've drawn a box, remember that the box acts as 1 dash. The box will get shuffled around with these individual dashes that are outside. So I have 5 dashes outside and 1 box. That makes a total of 6 things that need to shuffle around. So 6 factorial ways of arranging those things. Then remember that whenever you've drawn a box, what you do is you go inside the box and see how many different things are there. So there are 4 different things. So I'm going to say 4 factorial. Okay, there aren't 4 different things, there were 4 identical things. Still, I've drawn 4 dashes. So I'm going to say that I've gone inside the box and I've done 4 factorial ways. But I know that this is going to vanish because whenever I'm arranging identical things, I also need to divide. So there were 4 E's, so 4 factorial, 2 N's, so 2 factorial, and 2S, so 2 factorial. Let's see if that gives us the correct answer. The correct answer should be 180. Yes, the correct answer, this calculation gives me 180. Okay, so whenever you want to keep something together, put that in a box and shuffle it around. Then it says if the T is at one end and there is an S at the other end. Okay, so I draw a dash, I put T here. There are no other restrictions. 1, 2, 3, 4, 5, 6, 7, and there is an S. Okay, now these two letters won't shuffle around. The other 7 in the middle would shuffle around. So I'm going to say that this is 7 factorial. Now in these 7, what got repeated? There were 4 E's that got repeated and 2 N's that got repeated. But the S was fixed at the end and one S was shuffling around, so that didn't get shuffled around, so there were no repetitions there. And this is just one part of this answer. Just since it says if there's a T at one end and there's an S at the other, I must also consider this other idea where I say that this can also be possible. So I'm going to calculate one of them and then add it with the other one. 105. So 105 and 105 together make 210. I've added both cases together. Okay, so we learned something new in this question. Let's look at part B. It says 4 of the letters are selected from the 9 letters of the word Venezuela. So I am going to first write down Venezuela the way I write it. Okay, now remember that I'm selecting now, I'm not arranging, so I'm not going to draw those dashes. Find the number of possible selections which contain exactly one E. So what happens is E comes up and the other E's get eliminated. There is no selection of identical letters, and I'm going to emphasize that in a little bit, that you cannot select identical letters. You just have to borrow them and make a team out of them by writing down cases if there are cases. In this case, this was just one E, so I've just written down one E. Now, how many letters am I left with that I need to select? I need to select a total of 4 letters. So what I'm going to do is I'm going to say that I have 1, 2, 3, 4, 5, 6 letters available. I've already selected one letter, so I'm going to say that this is 6C3. Let's see if that gives us the correct answer. And yes, that gives us 20. Okay, please make sure that you understand this idea that I've eliminated whatever got selected. I did not do 3C1 for E. Why? Because there aren't 3 possibilities. There's just one possibility that the E gets selected. And they're all identical E's. There's no multiple selection for E's. Okay, let's move on to the next question. Let's find the number of different arrangements of the letters. 13 letters of the word accommodation can be arranged if all the vowels are next to each other. So that means that they are together. First, I'm going to write accommodation. Okay. So all the letters, all the vowels are next to each other. How many vowels am I talking about? 1, 2, 3, 4, 5, 6. Okay. So 6 inside the box. How many outside the box? 7 outside the box. And there's a dash. Okay. So 7 factorial. Sorry, 8 factorial. Why? Because the box also counts as a dash. 8 factorial. Then you go inside the box. Okay, how many are inside the box? 6 divided by what is identical? 2 A's, 2 C's, 3 O's, and 2 M's. All of these are identical, so they get divided by the number of identical elements. 8 into 6 factorial gives me a very big answer. So divided by 8 divided by 6, 604800. Yes, that is my answer, and that's written here as well. Okay, moving on to the next question. It says the 11 letters of the word remembrance are arranged in a line. Find the number of different arrangements if there are no restrictions. So first write remembrance in the way that I've been writing them. Okay, so how many different letters we are arranging? So I'm 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 factorial divided by 2 factorial, 3 factorial, and 2 factorial. Okay, let's see if that gives us the correct answer. 1663200. Yes. Find the number of different arrangements that start and finish with the letter M. So I'm going to write an M, then 9 dashes, 3, 4, 5, 6, 7, 8, 9, and then another M. So 9 factorial divided by 2 R's are identical, 3 E's are identical. The M's did not get arranged, so therefore they are not divided as well. So 9 factorial divided by 2, 30240. Then it says find the number of different arrangements which do not have all four vowels next to each other. So there can be three together or two together, but all four cannot be together, cannot be next to each other. Okay, so I'm not asking you to separate them completely. I'm just telling you to make sure that all four are not together. So in this case, what you simply do is you take the unrestricted arrangements and you minus together. Okay, why do you do that? Because you just want to make sure that all four are not next to each other. Three can be next to each other and two can be next to each other, but I don't want all four next to each other. So I'm just eliminating that possibility and keeping the unrestricted. So I'm going to say 1663200 minus together. And how do I keep them together? I put them inside a box. Okay, how many are inside the box? Four vowels. So 1, 2, 3, 4. Okay, so this is a subtraction sign. Let's write this as a subtraction sign. 1, 2, 3, 4, 5, 6, and 7. The box acts as a dash. So 1663200 minus 8 factorial because 7 dashes outside and the box acts as a dash. Go inside the box. 4 factorial. 4 dashes. Then divide by the identicals. 2 R's, 3's, 2 M's. This gives me 162216. Okay. Then the last part says four letters of the word remembrance are chosen. Find the number of selections which contain no M's, no R's, and at least two E's. Okay, so let's talk about that. R R E E E M M B A N C. No R, no M's, no R's, and at least two E's. What at least two E's means to me is that there could be a case with two E's and there could be a case with three E's. Remember that whenever you have identical letters that are getting selected, you never include them in the total. So you will keep them separate from the other letters and you'll try to make cases of those letters. So I've taken E's separately. I said there were two E's. Okay, I have four other letters. Now when I select two E's, I need to select two more letters because there's a total of four letters that need to be selected. So I'm going to say that B, A, and C, four letters are available and I'm selecting two out of them. Then because I've selected three E's, I'm doing 4C1. 4C2 gives me 6 and 4C1 gives me 4. So 6 plus 4 gives me 10. This is how you select identical letters. Make sure that you remember that. This is a repeated question on the exam. Gets more complicated as well. We'll talk about the complication in a little bit in the next question. Okay, let's move on. Let's look at the last question for permutations of letters. And this is a challenging one and it's going to bother you at the end a little bit. It says find the number of different ways that the 9 letters of the word aggregate can be arranged in a line if the first letter is in R. So I'm going to first write aggregate in the way that it's supposed to be written. Okay, so I've written aggregate, lots of repetitions. They start with an R and there are 8 more letters. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so those 8 letters get shuffled. There are 2 A's, there are 3 G's, and there are 2 E's. Okay, this should give you 1680. Let's quickly verify that on our calculator. 8 factorial divided by 2 divided by 6 divided by 2. Yep. Okay. Find the number of different ways that the 9 letters of the word aggregate can be arranged in a line if the letters G are together. So whenever you have together, you draw box. Both letters A are together. So another box. Both boxes have dashes between them. And both letters E are together. So E's are also together. How many are left outside? 3, 4, 7, and 2 are left outside. So how many things are getting shuffled? 1, 2, 3, 4, 5 things are getting shuffled. Then you keep going inside the boxes. 3 factorial for the first box, 2 factorial for the second box, and 2 factorial. What do you divide with? With all the identical ones. So 3 factorial, 2 factorial, 3 G's, 2 A's, and 2 E's. Okay, so in the end, I get 120. Now, a lot of people ask me, why did I write all of this when it's getting cancelled out? Because I'm following a simple principle that whenever you draw a box, you go inside the box and then try to do it. Okay. Then let's look at the third part. It says the letters G, R, T are consonants and the letters C and V are vowels. Find the number of different ways that the 9 letters of the word aggregate can be arranged in a line if consonants and vowels occur alternately. Okay, so there are 9 dashes, but those dashes are allocated 3, 3, 6, 3, 9. Now I have 4 vowels and 5 consonants, which means I have more consonants. I should start with a consonant, a vowel, a consonant, a vowel, a consonant, a vowel, a consonant, a vowel, and a consonant. Okay, I've written them below because I don't want to fix them in the numerator. Yes, they're all different. So let's first arrange the consonants which can shuffle around between themselves. Okay, let's shuffle them around. How many consonants are there? There are 5 consonants, so 5 factorial ways of doing it. Then there are 4 vowels, so 4 factorial ways of shuffling the vowels around. Now, were there any identical? Yes, there were lots of identical. 2 A's, 3 G's, 2 E's. I put this on a calculator and it gives me 120. Let's look at the fourth part. It says find the number of different arrangements, different selections of the letters of the word aggregate which contain exactly 2 G's or exactly 3 G's. Now I'm talking about selections. I don't need to draw dashes. That's what I know from my experience. Okay, so let's first write down aggregate. Now I told you to be cautious whenever you have repeated letters. It's not easy to do selection of repeated letters, which is why usually the marks are higher. Whenever you have repeated letters, you have to make cases. So there are cases which contain exactly 2 G's and exactly 3 G's. So the problem with G's is sorted out. The other problem that I have is that there are A's repeated and there are E's repeated. So whatever repeated letters are there, I have to say that I have to make cases of them where they get selected without any other letter getting selected. Okay, so let's say if I select 2 A's, how many other letters are there? How many other letters are there? 1, 2, 3, and 4. A's have been selected, G's have been selected. I have 4 other letters, but I don't have space to select anymore, so I'm going to say 4C0. I have G, G, E, E, so again I'm going to say 4C0. So that gives me 1, that also gives me 1. So those are the cases with 2 G's and 2 identical letters. Now there could be a case with two G's and two different letters. Now here is something important. How many different letters do you have except G's? You have A, you have R, you have E, and you have T. You have four different letters available for yourself that you need to select from. Okay, four different letters. I'm not double counting the A's, I'm not double counting the E's because the double counting element has already been catered to here where I got both A's selected. Remember that I cannot include the identical letters in my totals. Essentially, this should also have been 3C0 rather than 4C0 because I double counted the E's, so I should remove that and I should say how many different letters were available to me. There were three different letters R, E, and T. How many different letters are available to me right now? There are four different letters available to me, A, R, E, and T. So I'm going to say that I have four different letters. I've already selected two G's. I need to select two more letters because the question was about selecting four letters. So 4C2. 4C2 gives me 6. Those are the cases with two G's and two A's, two G's and two E's, and two G's and two different letters. Now those different letters could be A and E, A and R, A and T, R and E, R and T, and E and T. I'm not talking about arrangements. I've just told you all the six combinations that I was thinking about when I was doing this question. Now let's go out to the case with three G's. When you have three G's, you just need one more letter for you to complete that team of four letters. Now, how many different possibilities are there? Now, obviously, you can count, and they say that there are six different possibilities, but I'm telling you there aren't six. There are just four different possibilities because you can't count these A's as a separate team. They're not getting arranged, so they're not a separate team. They are the same person and same letter, so they don't create a different, sort of combination of digits or letters that you have. Okay. So just going to say that there are four different letters available to me, A, R, E, and T. So 4C1, that gives me 4. What is 1 plus 1 plus 4 plus 6? That gives me 12. Hopefully that is the correct answer. Yes, that is the correct answer. Now, there are lots of questions repeated like that, and there are some more technicalities. There's a question about the letters of the word tomorrow, and in that case, there's a probability involved. So it's there on my YouTube channel. If you are watching this video, make sure to also watch that video separately so that you understand the different complexities that I can create within this topic. Thank you for watching. I'll be back with now probably permutations of digits in the next video. Thank you for watching.